hopefully this works. Cool. Alright, Alright guys, welcome to the stream. My name's Vade, here from Learn APCSA. And today we're going to go over a few things about the Learn APCSA curriculum before we have that test on Friday. So, yeah, let's just get started. I'll look through all the things. I sent out a story on Instagram, got a few responses of what people wanted covered in their, in the live stream. So first one I saw, let me see. It was advanced array list methods. So array list methods in general, I think we've gone over that in one of the videos. Advanced, I'm not exactly sure what they're referring to by that, but yeah, we can just go over array list methods. If they're in the chat, they can clarify. So array list methods are not too bad in general. Array lists, you can kind of imagine them as a better version of arrays, or at least more intuitive for us humans to understand. The way they work is that they have a mutable size. So in arrays, the size is fixed. If you want to edit the size, you'd have to create that array, then, you know, create another whole new array with another size, make the first array equal to your new array, and you just have an entirely different array, basically. Array lists kind of do that for you. While they are based on arrays, and the whole documentation of them is using arrays and doing the whole process that I talked about, you don't have to do it yourself. Java already does it for you. The only downside is that using array lists does take up more memory, and it has, you know, longer, it has longer longer times to deal with each command. So for example, the add command in array lists, it adds an element in an array list. So you can add directly an element like e object to whatever array list you're adding it to. You could also do add and then do an integer, double I don't know why I did that, and do an integer, and this would be your index that you're adding it to. So whatever index you want to add your new object to, index and object, obviously. So whatever index you're adding it to, you can just specify. If you just do the first method, it'll automatically add it to the end of the index. If you do the second method, it'll add it to wherever you want. So if we have this array list here, let's just say it's an array list of characters. Let's go different. Usually I do ints, but this time we'll do characters. So this is C, this is F, this is A, and then, I don't know, this is capital A. Now let's say we wanted to add, what character do we add? Z. Let's say we want to add Z to this, this array. Then we would just say Z if we wanted to add it directly to the end. And that would make this array here like this. However, if we wanted to do this command, we didn't want to run this command, and we wanted to make Z the second thing in the list, right? We would say add at index 1, because 0, 1, 2, 3, 4, and then we want to add it at this index. So we would just say 1 and then Z. And that would just shove Z right into here. It would no longer be this. Everything else would be shifted down, and Z would become the new index 1. It's important to remember that every index after 1, because of this command, will have 1 added to their index. Sometimes they'll try to do something with that in the MCQ, and they'll be like, describe the index positions of every object in this array list after this position. You would just say index plus 1, because that's really what it is. Or they might try to get you to click some sort of answer for that. Like it might involve some for loop thing, and then it'll trip you up by saying every index before the added index, you have to do this to it. but every index after you add an index, you'd have to add 1 to that, and then do whatever you want to it. There's always going to be questions just like that. It's a pretty simple thing in general, but they might try to trick you on the MCQ, so just be able to remember these basics and how they work. Let's erase all this. What other methods are there in an array list? I guess there's get. Get is pretty self-explanatory. You're just getting the thing that you want, and it only has one version of it. There's no over. Man, why is the thing blanking? Why am I blanking right now? There's no other versions of it. It's just that one parameter version, get, and yeah. It's always going to be the integer of the index that you want to get. Yeah, I do. Pretty self-explanatory. Yeah. What other things are there here? Sets. There is set, and that can trip a lot of people up. So set is similar to get in that it involves an already existing element, but what we want to do with that element is we want to take the index of it and we want to remove it effectively and replace it with another element. If you just said set as replace, then it would be the same thing, because that's all it really is. You're just replacing an element. First argument is int index. The second argument is the object you want to replace it with. It's important to remember that set returns whatever object was there. So return type E. It's kind of like remove in that sense, I guess you would say. If you wanted to do the remove method, remove int, whatever, then you would just return whatever you removed. Pretty simple stuff, but it's important that you remember these basics because they will try to trick you up with these more complicated looking code bits, and they're all just really simple. So don't worry about it. Alright, what other requests do we have? I know we had array list methods, so let's go to the next one. Selection sort, and merge sort, and insertion sort. Yeah, all the sorting algorithms. Alright, let's look through it. So selection sort is pretty interesting, I guess, among sorting algorithms, in that it doesn't look like it would be that effective, but it's pretty much as efficient as the other ones. So let's say we had a list of, I don't even know. Let's say we had a list of a bunch of ints. It's probably the easiest way to explain it. Why am I doing quotation marks? 5, 1, 12, 17, and 9, 3, and 10. It's so many. Okay. So if we wanted to do a selection sort algorithm, actually first off, let me start off with a visual of what selection sort typically looks like so we really understand this. So right here, visualization. Okay, so you see it goes through all of this. I'm gonna kind of skip ahead. We see it goes through every single one of these elements, right? And it phases through them. Every time it goes through an element, it compares each element to the previous min. So what it's storing in each loop is this min value, where it is and what the value is. Eventually, once you go through every single element and you've compared every single element to the current minimum, if that minimum is still, I guess, the minimum after going through every element, then we just put it up front and we cycle through every other element except for the one that we already sorted. And this kind of pattern remains the same. Yeah, you can see. So every time we go through it, it starts to get faster and faster, and that's because we're going through the list that's shorter, right? Because this little segment of the list right here, it's already sorted. We don't need to go through it and check which one's the minimum. We already know. This part, though, the unsorted part, is what we're actually cycling through each and every time. So every time we're doing it, we're kind of shortening our search. It's an important thing to remember. We're, I guess, shortening the area that we look at in the list. Yeah, I guess that's all there is really to it. It's not too complicated if you can visualize it in this manner. It's probably my favorite way to visualize it, is this big list, and you cycle through it over and over again. So let's look at this now. Right here, we started this first value, that's 5. So our little minimum variable, we're just going to make it called min, why not, right? It's 5. The index, we're just going to say it's at 0. So we had the first element, and because we haven't looked at any other elements so far, we think that the minimum of the entire list is 5. But then we go to the next one and we're realizing, oh, okay, wait, this is 1. 1 is less than 5, so minimum is now equal to 1. And the index is equal to 1 as well. And then we're like, okay, go through every other element, and we're all like, okay, yeah, none of this is less than 1, right? So we create a new list that is switching 1 and 5. This isn't like a thing where it'll just switch the positions over and over again. Typically what it is, it will, oh my god, is it will switch the two positions like directly. It won't switch the adjacent positions, like it wouldn't, like imagine 1 was right here. It wouldn't switch with 9 and then switch to 17 and then switch with 12. No, it's literally like switching these two positions directly. So if 1 was right here, it would switch directly with 5, and 5 would end up at the very tail end of the list, despite starting right in front. That's an important thing to remember. Although there are different versions of selection sort, it's the one you're probably going to see on the AP exam, so, you know. Let's erase all these arrows. So now that we have the first smallest element right here, we're just going to create a little wall, and then this is the partition that separates the sorted from the unsorted. Alright, our new minimum, looking at the first element here, is also 5. I'm just going to get rid of the index because it might get confusing, but, you know, that still exists, right? So, we have 5 right here. Let's get that 5. Yeah, I agree. Sai Burjala. So, we have this minimum right here. And we look at 5. We're like, okay, yeah, that's our minimum. Then we look at a 12. 12 is not less than 5. Go to 17. 17 is not less than 5. We go to 9, a little closer than the other two. It's still not less than 5. Then we go to 3, and we're like, okay, wait, that's less than 5. So our new minimum, because 3 is less than 5, is equal to 3. Yeah. And then we look at 10. Yeah, 10 is not less than 3. So we just sort that part right there. Our new list is 1, oh my god, 1, 3, 12, 17, 9, 5, 10. We switched 3 and 5. So 5 is now there. And then we just keep on going, blah, blah, blah. 1, 3, 5, 17, 9, 12, 10. And then 1, 3, 5, 9, 17, 12, 10. And eventually we just keep on sorting and sorting. I'm just going to skip to the very end here. And we get our final sorted list, which is this. That is not 5. I don't really know what that is. But yeah, that's what our list is. Really understand everything this guy is saying. He really knows what he's doing. Thank you guys so much. I appreciate it. I'm trying my best here. Alright, so that's kind of a little review of selection sort. We're going to try to speed up this process that we got to go through here, because at 5:15 I want to start going over FRQs, because that's what a lot of people are saying they need help on. So, alright, blah blah Let's go to insertion sort. So insertion sort is roughly the same kind of thought process that you would do with selection sort. You just got to think like an algorithm, honestly. Say we had the same list or whatever. I don't really remember what my list was. 5, 12, 17, 3, 10. Yeah, let's just do that. 5, 10, 12, 17, 3, 10. Yeah, let's do that list. First, let's do the same thing we did before. BOGO sort. If you guys have seen that, you know what it is. But, right here, we start. Oh my god, this is so loud. So, a lot of people get this sorting thing confused, insertion sort, with selection sort. Selection sort is just looking through the entire array, and then we find the minimum and we put it right at the very front. Insertion sort is kind of like an impatient version of selection sort. We're not looking through the entire array at once. What we're doing is that we're finding each minimum value through each comparison, and then we switch it directly. Learn APCSA. Thanks, man. Alright. So every time we switch it, that's kind of like the one that's at the very beginning of our list is our new minimum value. And that can be redefined over and over again. It's not like selection sort where the first time we go around, that's the absolute minimum value in the list. But yeah, we just keep making comparisons until each element is in the right place. I'll just let this play out here. Oh my god. This noise is really irritating. So you can see this little element right here, it was pretty short, and it just got sorted all the way into the front. So if selection sort is about finding that minimum and then shifting it right into the very front, insertion sort is all about comparisons and shifting. And that's going to be the main thing that you're going to see. So yeah, it's a lot of comparisons. Yeah, let's go to this. Right here. So we're starting here, 5, 10, 12, 17, 3, 10. So 5 and 10, these two seem to be in the right place, so we're not really going to adjust it. Yeah. 5 and, 2. 10 and 12, these two also seem to be in the right space, so we're not going to adjust it. Oh my god. Wait, did I fit 10 and 12? Okay, let's just say this is 19. Yeah. 12 and 17, these also seem to be in the right place. It's kind of boring. 17 and 13, though, these two do not seem to be in the right place. So now we have to actually make our comparisons here. So 17 is greater than 13, which means, or 17 is greater than 3. Did I say 13? I don't know. So we're going to switch those two around. Now we're going to compare 17 and, or 3 and 12. So 3 is less than 12. We got to switch our thing around here. And now we have 3 and 10. 3 is less than 10. We're going to switch that around. 3 is less than 5. We're going to switch that around. Eventually we end up with 3, 10, 12, 17, 19, which is already sorted. That was kind of boring. But you kind of see the thing that we're going through here. We're not looking through the entire list at once. This is all about immediate comparisons with things that are adjacent to us. So, yeah. In selection sort, what you would be doing is you compare the first element to every single other element in the array that is a minimum, right? So if the first element was 5, you compare it with 10, then you compare it with 12, then you compare it with 17, then you compare it with 3, and then you would find out that 3 is less, and then you would switch it. With insertion sort, you're just comparing 5 and 10, and then 10 and 12, and then 12 and 17, and then 17 and 13, or 3. And then if you find one that is like one pair that's not in the right place, you would then start switching over and over again. Yeah. We're going to think about this algorithmically once we get to the FRQ bit, but as we are running out of time, we're just going to skip over some of the stuff. And then the last one they wanted us to cover was merge sort, which is kind of irritating, but, you know, it's merge sort. Alright, let's look at the thing for merge sort, just to remind us. I actually did have a video about this. Did I? I think so. Yeah. this noise is so irritating. But you can see what's going on here is that we're basically subdividing all the parts of the list into their own little subsections. And this happens over like a recursive thing. Right here, we're doing it in a... Can you guys actually see my face? Just making sure. Alright, cool. So, oh, what's the big O of this sort? The big O of insertion sort? That would just be O of N, I believe. The big O of sorting an entire array. Insertion sort. Big O. Yeah, that's just O of N squared. Oh, for best case it is O of N, but I don't think you need to know that. Okay. If that's what you were getting at, then yes. Cool. Actually, yeah, let's go over the big O's of these algorithms. That's not APCSA curriculum. Yeah, never mind. Alright. Moving on from that. The only real one that you need to know time complexity of is, no, you don't even need to know time complexity for merge sort. Yeah, never mind. Alright, cool. Let's move on. So you can see we're just subdividing the array over and over again. The way it's shown in this video is a little bit inaccurate to how it actually plays out, because if it was a little more accurate, it would be like everything is happening at once, because we're subdividing everything over and over again. Like, it's not happening like this where we're just focusing on one part and then we combine those two and then the rest of the array is just chilling there, right? We are doing this to every single part of the array all concurrently and parallel, which is why merge sort is so, efficient. It's recursively dividing each part of the array and then grouping them together. So right here, we're just dividing these into these little parts. We're going through them and we're sorting each of them. The sort is, I believe, the same as insertion sort, yeah? In that you would compare each element to, no, but it's not the same algorithm. Yeah, don't think about it like that. So what you're just doing is that every time you combine the two parts of the array, you compare each individual element in each part of the subdivisions, and you would see which one goes where. That's pretty much about it. Don't think about that part too hard. I don't think they would test you on that. But every time you have a subdivision of an array that's an equal length to another subdivision of that array, you would just combine them and you would compare each individual element to each other and sort it from there. The whole reason why people say this is very efficient is because of this combining process. It allows something that insertion sort and selection sort can't have in their worst case scenarios, because they're constantly running these inner for loops and things like that. Merge sort is a bit different in that regard. That's also why we say recursion is super cool and why we introduce merge sort with recursion. It's because it's probably the best application of recursion in APCSA. Your great hair. I like your hair a lot. Thank you so much. I don't feel like doing a thing for merge sort because it's kind of complicated, but I can write a bit of an algorithm right here. If I can load up the Java online compiler. Which one should I use? I'll do a bit of pseudocode. It's a bit complicated. Okay, so all you need to know, if you were trying to identify what merge sort was on the test and they gave you like a code snippet, all you really need to know is that it's calling itself over and over again while it's subdividing its array. Calling own method. Yeah, let's just say that. And then, yeah, that's a pretty dead giveaway that it's merge sort. Whereas if it was insertion sort, then you would want to actually look for the comparisons. And typically these comparisons would happen in like an inner loop of sorts, because when you're doing insertion sort, you're going through the entire array, and then for each individual element in the array, you're comparing it to its adjacent element. And then that's when you're looking for that, the thing inside the inner loop, which compares each element and then switches them around if it's in the wrong place. So switching places in the inner loop. And then for selection sort, I guess you could say, let me erase this merge sort thing. For selection sort, a pretty good thing to look out for is just if it's going through the entire array and it has that sort of constant variable that's like keeping track of what the minimum is in the for loop. Right here. So if that's something that's happening in the for loop, then it's a pretty good giveaway that it's selection sort, because we're keeping track of what the absolute minimum in the list is, and then we're switching places with that, with the, first element. Yeah, these are just helpful tips. Sometimes they'll have like code snippets, and you'll have to identify what sorting algorithm it is. So it's good to know sort of the giveaways for what you're looking for if you need to identify one. Other things you could probably remember, merge sort is the divide and conquer algorithm. I'm sure you guys know why, but it uses recursion to divide its own, list over and over again, and then it sorts within that list. Yeah. Mr. APCSA, can you go over the new material, reading files, and using scanner? I would love to. Alright, so there's a cool introduction this year, I believe it was this year, with introducing reading files and scanner and all that. So it's actually not as bad as it looks like. So let's go over just using a scanner first. I'm sure you're all familiar with it, but when you're using the scanner, you do need to import java.util.scanner. Oh my god. java.util.scanner. This will allow you to import a new scanner object. And then let's just say that this is the main code, because I don't want to write the main method, alright? I'm a little lazy. But, let's just call our scanner SC, keep it simple, and yeah. New scanner. So it's just like when you're importing an actual new object, you would do the same for a scanner. And then the thing inside of this, these parentheses, the argument that you're putting in there is pretty important. So let's say you wanted to just read what's in the command line. You would say scanner and then put in here system.in. And then this is basically saying whatever we're reading from the command line is what the scanner is. We're scanning whatever's in the command prompt. So let's say we had, I don't know, they're supposed to put in like a number. Then we would say sc.nextInt, or we could store that in a variable. We're not just gonna say that. Okay, we could say sc.nextInt something, and then we could like print that out or something. Yeah, but system.in is pretty easy. I'm sure you guys are all confused about the files though, which is also actually not too bad. So let's just erase this, if it will allow me to erase. Right now my computer is, I'm running this on a laptop. I'm just letting you guys know. This is not a PC setup right here. So we are struggling. Yeah, cool. Let me erase, please. You guys see this? Okay, cool. So for files, first thing you need to do is make sure that in your main method you are saying, okay, it's not letting me do this. Yeah. Okay, I'll just describe this here though. But you have to make sure that in your main method you are describing that you want to throw this IO exception. This will happen typically with when you're reading files. The input-output reader can throw an exception, and if you don't put this throws IO exception right after your main method, it's not going to run properly when you're trying to read a file. So it's important that you just put that there if you're ever doing this on an FRQ, so you know the compiler doesn't throw a fit. But throws IO exception, make sure to put this after your main method. Oh, yeah, and of course, import java.io dot, I don't know, I think file, yeah. Java.io dot file. So after we've done this throws IO exception thing, we're going to, let's just make a scanner. Scanner sc equals new scanner, and then we can make it read a new file. So we can just say new file right here in this argument, and then put whatever file name we want to read. Let's say some dot dat, yeah. And then from here we can just do the normal things that our scanners do. Yeah. So scanner methods are pretty interesting. All they are just next, which just reads whatever's next. It's delimited by spaces, specifically white space. So let's say we have this input right here. Hello, world. Then if we did dot next on this, because we'd find it in a scanner, I guess, then it would pull right here, and that's what we're reading. That's the thing the method refers to. Hello, comma. And it wouldn't include the space, so it's important to remember that. It's delimited by spaces, so that means as soon as it sees a white space character, it stops and kind of chops off the input right there. Next line is a bit different, and that's because what we're reading doesn't just stop at spaces, it only stops at a new line character. Every time we have a new line in Java input, it's recognized in the compiler as a \n. That happens whether you say \n in the input or whether you just put a new line by pressing enter. But yeah, so every time we encounter this new line or \n, we stop reading. So for the same hello world input, we wouldn't just stop at this space right here. We would read the entire hello world and then just stop there. Yeah, cool. We are lagging out. Okay, yeah, almost crashed there. But did it get a lot brighter? Alright, we won't worry about that too much. So, how is the FRQ like? Is it a regular text response like College Board does for other exams, or do they have their own special thing for APCSA? So it's the regular text response thing the College Board does, but the way you format it is a bit different. It's kind of like you're formatting it directly into like the compiler. So when you're typing it in, College Board will have their own little special things that allow you to do those indents that you would typically see if you were typing it directly into a Java IDE or something. So you could do like tab, you could do all of those things. You have to press semicolon, you have to type actual lines of code. It's not just like a text response where you're typing things like sentences. you're genuinely typing it like you would type it into a regular compiler. So yes, it is in the same style as other AP exams, but you're not writing sentences, you're writing code. I don't know if that makes sense, but let me know if it does. Yeah. Okay. If we have no other questions, we can start looking at FRQs in a bit, because my screen randomly turned off night mode and my eyes kind of hurt. Just a reminder, fellow computer science majors, that when you are using your screen, try to keep your monitor or display on night light as often as you can, just to reduce the amount of blue light that you're taking in. Sometimes it can really disturb your circadian rhythms, and that's especially for all my CS nerds out there that are up all night doing hackathons or whatever. Just make sure to remember to do that for yourself. Alright, let's look at some past FRQs. 2025 APCSA FRQ. Alright. I'll pull up the scoring guidelines, but we won't look at it immediately. If I get something wrong, that's low-key oral loss, but, you know, whatever. Alright. You guys can see this. Probably. Yeah. Can you see this? Is it displaying my, thing right here? Alright, give me a sec. Just technical difficulties. Making sure that we are able to access this. Alright, you guys are not able to see this. So let me stop this display right here. And then change it. Oh, that worked. Okay. I have no idea why that worked, but whatever. Alright, yeah. Cool. So question 1 from the 2025 APCSA FRQ. So this question involves dog walkers. You can kind of see how it's formatted. Basically, it'll say what the setup of the whole thing is, what the algorithm is trying to do, and then it'll describe what you have to do yourself. It'll give a bunch of methods that you can kind of assume what they do, but they don't actually show how they're implemented, because not because they want you to do it yourself, it's just because you kind of know what it returns. You don't need to see how it's implemented. So yeah, College Board isn't out to get you with this. They just kind of describe what it does already. So this question involves dog walkers who are paid through a dog walking company to take dogs for 1 hour walks. A dog walking company has a varying number of dogs that need to be walked during each hour of the day. A dog walking company is represented by the following dog walk company class. So this class kind of represents the entire company as itself. It's important to remember what each class is representing, otherwise you can kind of get it twisted in your head. So this thing right here is the number of available dogs at any given hour of the day. So the precondition for an hour is that it's between 0 and 23, 0 and 23 included. So public void update dogs. So okay, yeah, it decreases the number of dogs, or by number of dogs walked, the number of dogs available for a walk during the time specified by an hour. Think about the possible implications of this, what you would want to use it for. So probably just somebody takes a dog, then you would run update dogs and, you know, reduce the number of available dogs by 1. There may be other instance variables and other things that aren't shown, doesn't really matter. A dog walker is associated with the dog walking class. So this is the class for dog walkers. Notice the distinction between dog walkers and dog walk company. So the max dogs a dog walker can simultaneously hold is this. This can vary between dog walkers, so yeah. It also has a private instance variable for the company that it's associated with. So yeah, it can do company dot whatever and make calls to this dog walk company thing right here. And then it has this constructor, implementation not shown, obviously, but it would just define the instance variables. We don't need to see it. And then walk dogs. This is the one that we're doing in part A. So what it's asking for us to do, part A, write the walk dogs method. What it's asking for us to do is write this method right here, walk dogs. So it takes one dog for a walk during the specified time by hour, as described in part A. So we would put in an hour, and we would take a dog for a walk. The things we would probably have to do is we'd have to update the number of dogs that there are with this method right here during that hour. And we'd probably update some other thing right around here, dog walk shift, I would assume. And yeah, so right here in part A, it kind of describes literally everything you need to do. I would say that skim over this, but make sure that you pay a special attention to these like lines that kind of shift fonts, because these are the things you're going to need to refer to during your writing process. So write the walk dogs method, which updates and returns the number of dogs this dog walker walks during the specified hour. So we're returning the number of dogs that the dog walker is walking. Alright, seems simple enough. A helper method, non-available dogs, has been provided in the dog walk company. Another helper method, update dogs, has also been provided there. So we need to take at least one dog for a walk during that time specified. Okay, this is interesting. Their helper method, update dogs, has also been provided. Dog walk company. If the dog walking company has 10 dogs that need to be walked at the given hour, but the dog walker's maximum is 4, then the update dogs method should be used to indicate that this dog walker will walk 4 of the 10 dogs during the given hour. Okay, so to my understanding, what we're going through here is that the dog walking company has a number of dogs that they need to be walked, and our dog walkers each have a max amount of dogs. So what they do is that they take the max amount of dogs that they can do in an hour, and they just walk them, and then we update this method right here through update dogs, and we update the amount of available dogs that other dog walkers can do. Yeah, that's cool. Take at least one dog for a walk during the time specified by an hour. Yeah, cool. Alright, let's get to writing. Program. Okay, program is Java compiler, and we're gonna start writing this method. Okay, you guys can see this now, but you couldn't see the other thing before. That is so weird. I don't know why. Alright. We're not gonna actually run this in this compiler, but this is just another way to do this here. Public. Let's copy the method header as well. This is another thing that you should do right before you get started on anything. Copy the method header, because otherwise you're going to forget the name. Otherwise you're going to forget to write the method header at all. Otherwise you're going to forget what you're supposed to return. It's just a good way to start off any good FRQ. Public, what are we doing? Public int walk dogs. Dogs int hour. Cool. So the first thing we're going to have to do is, alright, we have our int hour, and what do we need to do in the first place? So first thing we need to do is we need to define if there are actually dogs to walk in the first place. Think about the edge cases in general, and then you can think about the original code. Actually, let's think about the edge cases later. So the first thing we need to do is kind of define what we want to do for any general case. So company is defined as company in here. And the thing we want to do for our dog walking company is we need to update the amount of dogs in the company by the max amount of dogs we can walk. So first we'd need to find the amount of dogs that we can walk, which is int and then dogs to walk. Yeah, dogs to walk. you don't technically really need to obey by variable etiquette for names, but it is better to do that because there's more likely of a chance that you'll get partial if you accidentally mess up on something. So just try to do something that's reasonable for your variable names. From there, alright, we define the number of dogs that we can walk by the amount of available dogs that there are in the company, probably. So we could do that one method that we have in company, which is up here, num available dogs. Company.num how do you spell that? Available dogs. Gotcha. And then from there into hour, so we would just plug in hour right there, and that's the amount of available dogs that we can walk, and we haven't really adjusted it for the amount of dogs that we can like maximum walk, so we would probably need to do sort of an if statement. What would we do if the if the dogs to walk is greater than, what is the maximum called? I was trying to think of that. If it's more than max dogs, could we do this another way? Company dot. We could probably do a mod thing, couldn't we? Just to impress them. Yeah. Okay, so let's just do this. So the company of the number of available dogs, and then we mod that by the maximum amount of dogs that we can walk for this, the specific dog walker. So company.max dogs, would that work? If we had like max dogs is 4, company dogs is 10, what 4? No, we couldn't do that. Yeah, no, that wouldn't work. Am I thinking of something wrong here? Maybe I should stop doing too much and just do an if statement. Yeah, no, because if it's more than... Yeah, okay, we just gotta do an if statement here, man. I'm trying to do too much. Alright, so dogs to walk, if it's more than the maximum, max dogs, I think that's what it's called, then we would return, or we would make dogs to walk equal to max dogs. And then otherwise, we would just get all of the available dogs, because if we can take more, why not take more? Then we would do update dogs, whatever the parameters were for that. Update dogs int hour, because we already have hour, and then number of dogs walked. We would do dogs to walk. And then from there, what else would we do? What else is it asking us to do? Update dogs. Do we have to return something here? We do, int. What are we returning here? Return the number of dogs to be walked by this dog walker in the specific hour. Just return dogs to walk. Return dogs. Oh my god. Dogs to walk. Another reason that we should be using variable etiquette. So, yeah. Because I read this and I saw that we should return the dogs to walk. I named my thing dogs to walk. Makes it easier, saves time, all that. Yeah, use variable naming etiquette. Part B, what are we doing here? Write the dog walk shift, which performs the dog walking shift of the hours in the range start hour to end hour inclusive. Returns the amount. Okay. Total amount earned. So this shows the calculated thing. So if the hour is at, okay, wait, for example, a dog walking shift from 14 to 16 is composed of 3 1-hour dog walks starting at 14, 15, and 16. For each hour, the base pay is $5 per dog walked plus a bonus of $3 if at least one of the following is true. Max dogs are walked. Dog, go to sleep. Alright. X dogs to walk. That. Base pay $5 per dog. Okay, so these are the little exceptions that we need to take care of when we're writing this method. So generally, the base pay for each dog is $5, but a bonus can also be added if one of the following is true: that the max dogs that the dog walker can walk is, reached, and the walk occurs between the peak hours of 9 to 17, which is inclusive. Okay, yeah. So right here we can see these kind of calculations. So the number of dogs that we walked, number of dogs that we walked is 3. The maximum that we can walk is 3. The hour is 7, which isn't between 9 and 17, but we still earn the bonus because we walked our max amount of dogs. So we do 3, and then we would do times 5, which is the base pay. Then we would add a bonus of 3. Total is 18. Okay, pretty easy. So right here, I'm assuming we would use, walk dogs. Yeah, alright. Does it say that in here? Yeah, you must use walk dogs appropriately to earn full credit. Sometimes they'll give you little hints right here. Use walk dogs. Yeah. Public. Alright, let's start with the header. Public int dog walk shift. Dog walk shift. And then, what are we taking as parameters? Int start hour, int end hour. Int start hour, int end hour. Cool. So these are parameters. This is the hours that we're given. I believe these are inclusive. Yeah. Dog walking shift from 14 to 16. 3 1 hour. Yeah, 14, 15, 16. So these are inclusive. So if we had int start hour equal to 14, int end hour is equal to 16, then we get paid for all 3 of those hours, right? Because we're ending at the very end of the hour. Yeah. Just something that you make sure you don't want to get tripped up on. Alright. So first thing we should probably find is the amount of hours we worked. End hour minus start hour, and then I would say plus 1. So think about that algorithmically. What the heck? Okay, so if end hour was 16, minus that by start hour, which is 14. That's 2 hours, but we actually worked 3 hours because end hour is counted at the very end of the hour. So we would add 1 to that, which is 3 total hours worked. And alright, yeah. The walk occurs between the peak hours of 9 and 17. Calculated by walking dogs from hour 7 to hour 10. So for each individual hour, there is the thing that's calculated. So each individual hour, okay. Oh, I've been approaching this wrong. Yeah, no, each individual hour is calculated separately. Yeah. So we would need to... Right. Got you. Okay, so okay, we actually do still need to do that though. I don't know, I got rid of that variable so fast. So we would need to do a for loop and loop through all of the hours that we've done. And then, yeah, okay. Alright, yeah. So for int I is equal to 0. I is less than hours. Alright, bro. I is less than hours. I plus plus, then we increment the entire list. And then we calculate the amount of dogs that we're walking per hour. And then within this for loop, we keep on adding stuff. And then, what are we returning? The total amount, I would assume? Yeah, total. Return. Wait, what are we returning? Why doesn't it say it here? Returns the total amount earned. So yeah, we're just adding everything. We can also do a variable right here. Total equals 0. And then for each hour, we are... No, yeah, because we would need to start with that too. So start hour, and then I is less than end hour. And then because we need to reach end hour, we would do I is less than or equal to end hour. Got you. Alright, see, it's all clicking into place. So for each hour, we need to do int, or wait, int add is equal to, or we could just do total plus equals total dogs walk dogs I, and then times 5, which is our base pay. So that's the amount of dogs that we walked. Alright. Ooh, but no, we need if statements for that. Alright. No, yeah, we could do that. Total plus equals, so we add the base pay, and then if either of these conditions are true, which the conditions are max dogs are walked, or the walk occurs between those hours, if, we need to define that through here. Int, yeah, okay, let's just do this. Int dogs is equal to walk dogs I, then right here, int if dogs is equal to max dogs, or if what's the other condition? The walk occurs between those two. All right, if start hour, no, or if no, yeah, you couldn't do that either. Let's make a boolean for that actually. Boolean bonus equals false. So if these dogs are walked, then we make bonus equal false, or true, yeah. All right, and then if our is less than, no, greater than 9, greater than or equal to 9, and our is, no, I, yeah, we're calling it I, my bad, and our is less than or equal to 17, I believe, yeah, 17, all right, then we also make bonus true, and then walk dogs, and then we do total plus equals dogs times 5, and then oh, but how can we make this the best algorithm possible? Alright, yeah, let's just make this like that. If bonus, then total is also equal to 3, or plus equal to 3. So, yeah, that technically works. It's a little bit ugly. You could make this better, for sure, but that's what I got. Yeah, that should work. Forms an entire dog walking shift and returns the amount earned in dollars as described in part 1. We do need to return the amount. So return total, boom. Must you walk dogs appropriately? Yeah, that works. And let's check this right here. Alright, let's check our methods. So, question A, part A looks pretty spot on to what I've got. Oh, they use the same variable name as me, that's so cool. Dogs to walk, yeah, the solution uses the same variable name as me. Am I low-key a bot? Am I a bot for that? Alright, question 2, start hour is less than or equal to, and hour, I plus, plus equals 3, yeah, cool. Okay, yeah, no, these solutions look pretty spot on. If you guys want to see how they did it, yeah, we got it right here. All right, so these are the actual solutions for the FRQs. Pretty spot on to what I did. Yeah, just make sure when you're doing these FRQs that you're looking at the method header, you're writing it down immediately into College Board as soon as you, or the entry space as soon as you see it, and then you're remembering, oh, I've got to return this at the very end. See, me right here, if I didn't go back and read what they actually wanted from me, I would have totally forgot to do return total, and I would have gotten the question wrong because, well, I would have gotten partial, but you know, it's important to get these very like easy points right here, right? So yeah. Also, always make sure that you are understanding what it's going to do in like a real life implication, because it wouldn't particularly, if it doesn't like make sense if you were to apply it to real life, then that's probably not what College Board wants you to do. The whole goal with these FRQs is that it's training you to be somebody that can use computer science in the everyday, like day-to-day world, right? So if you don't understand what the problem is trying to say or trying to get you to do, then that means you're probably not going to write the code very well, and you can try to skip the problem for now, go to something that's easier, and while you're on that other FRQ, your mind can ruminate on what that was asking you before. That's what I usually would do for a strategy if you're struggling with the FRQs on the exam. Sometimes they can honestly be less of a coding test and more of a reading comprehension test, and you really just have to understand what it's asking of you before you start typing away. Sometimes it can be very stressful during the AP exam, especially when you open the FRQ, you're like 2 minutes in and people already start typing away like, you know, it's their last day on earth or whatever. But just be patient, be efficient, make sure you're reading it properly over and over again, make sure you understand what the method wants you to do, and you understand all of the other methods that you have to your disposal, and if you write a good algorithm, that's good. It doesn't always have to match exactly what it says on this key. You don't have to think of it like coding is some rigid thing where there's only one solution. There are multiple solutions to the exact same problem. All you have to do is find one of them. Yeah, that's kind of how the FRQ is formatted. I did this to kind of show you guys what you are to expect when you're doing this on AP exam day. It's also going to be on a Friday afternoon, so I know some of you guys are going to be locked out, but you know, log in, right? Just make sure you understand. Also, I will say it is very easy to get a 4 plus on this exam. I knew somebody 2024 they did the exam. They wrote return null on half of their FRQs, and they still got a 4. So that's the kind of people that we're competing with. So if you have a pretty basic knowledge and understanding of this kind of course, you can understand all of these questions, what they're asking of you, and even if you don't, you give a good try, then honestly, you've got a pretty good shot at a 4 or probably a 5. So yeah, don't worry too much about passing. Worry about getting the best score that you possibly can. Alright, yeah, these ones are kind of boring. But I do recommend doing these on your own spare time, then going to the rubric right here and seeing how you did. And just remember, don't look at these model examples right here. These canonical solutions are not the only way to do these. Look at the scoring criteria because that's what people are actually going to be judging you on. AP graders don't just judge you on whether you did the exact canonical solution. That would be ridiculous. So yeah. Another thing to remember is that APCSA is not an efficiency class, so even if your method doesn't run as efficiently as it could, doesn't really matter, as long as it gets the job done. Alright, yeah. Every question, try or attempt something. Don't just leave them blank, especially these FRQs, because it is very, very, very easy to get those points. Let me show you the scoring criteria for this first one. So for this one of the scoring criteria is just that it calls dog walk companies methods with company. So even if you got the entire thing wrong, if you just wrote company dot something and you did something there, you got a point. If it compares the available dogs and max dogs to determine the number of dogs to walk, so that's what we did right here. As long as you make some sort of comparison, you get the point. And responses can still earn the point even if they call num available dogs incorrectly. So they don't even have to do, you don't even have to do company.num available dogs. You could accidentally write just num available dogs, or you could do this and not include the hour. You would still get the point. It probably wouldn't get you other points, but I'm just showing you, it is pretty easy to get these partial credit points. Returns calculated value. Responses can still earn the point if the incorrect number of dogs were walked. Call num available dogs multiple times. Yeah, as long as you return a calculated value, you're gonna get a point there. Like, these are pretty easy points to get. You don't need the exact correct algorithm for all of these. So, yeah. Yeah, so that's what we've got going on here. Alright, in this part of the stream, I wanted to designate this to something that I like asking the chat, Q&A sort of thing, for this last 20 minutes. So, if there's anything that you guys are still confused on, or you just want us to explain directly, then go ahead and ask. There are no dumb questions. I want you guys to be able to speak your mind and just really get it all out there before this exam. Because if there's any time to ask it, it is right now. So anybody in chat, if you guys have any questions for us, go ahead and ask them. Right, looks like we don't have any questions in chat. Cool. Alright, with that, I think we have covered everything. Let me go ahead and check if there's anything that we missed that people wanted to get covered. And if not, we can go ahead and end our stream here. So, last minute things. Something hard like recursion. Yeah, recursion could be good to go. Oh, but there is a recursion video on our thing, and I feel like we'd be restating it a lot. So, just a quick plug for our own channel. If you are ever confused on anything, we've got a bunch of videos right here, and we're going to be coming out with more mini review videos in the form of shorts and Instagram reels in the coming months. So, yeah. Can you discuss polymorphism? That is a good one. I don't think we discussed that on the channel yet. So, yeah, let's go ahead and talk about it. So, actually, let me check if inheritance is still covered on it. Yeah, got a bit of lag here. Oh, blue light just turned on. Ugh. Let me check the display settings. Is inheritance still covered in the APCSA exam CED? Do you know that? No. Inheritance is removed. So yeah, I don't think we're gonna need to cover polymorphism for this stream currently. Unless you guys are interested in seeing me cover it, which, I'm always down to, make some learning things. But yeah, that is outside of the scope of APCSA. I think we're gonna try to focus on other things currently. Let me see if I skipped over anything here. FRQ, response. Alright. Doesn't look like we have much more things that we have to cover. Yeah, so thank you guys so much for tuning into the stream. If this helped you at all, then be sure to share our channel to anybody that could be interested in this sort of content. So, yeah, feel free to click that like button, subscribe, all that if you're not already. But, Yeah, make sure to, if you guys still have questions on any of this curriculum, be sure to message our Instagram, which I can link in the description or somewhere, and make sure to message them asking for specific course requests or topic requests for our shorts that we're going to be doing in a couple of weeks leading to the exam. Yeah, that's all the material we should have to cover today. Thank you guys so much for tuning in once again, and yeah, I'll see you guys later. Alright, and